In this video, we're going to talk about stoichiometry. So hopefully now you can balance chemical equations fairly readily. But if you can't, we're going to practice here anyway. I'm not going to set up the little setup like I have in the previous video, but we're going to just count atoms in, atoms out, and see if we can get them to balance. So here in stoichiometry, in balancing chemical equations for combustion, this is a combustion reaction. We start with carbon. Okay, we have two carbons here. We only have one carbon there. So we need two CO2s in order to give us two carbons. We have 6 H's. Here we have 2 H's in one molecule of H2O. How many molecules of H2O will give us a total of 6 hydrogens, and that will be 3. 3 H2Os, 3 times 2 will give us 6. And finally then we balance oxygen, but we count at the right side first in combustion. We have 3 oxygens here. I'll just jot a little note, 3. We have 4 oxygens here. So that's a grand total of 7. It's odd. So this is an example where we don't have an integer on our initial balance of balancing a chemical equation. The number that'll give us 7 here, 7 halves of this O2 molecule, will give us 7 atoms of oxygen altogether. But we can't have that. We can't split oxygen molecule in two just for the sake of doing this reaction. All right. If we could, then we can just alter any of these formulas to our will, but that's not how it works. But this is balanced. One of these, 7 halves of these, gives us 2 of these and 3 of these. All right, now, that being the case, what do we have to do in order to get this balance with all integers? Well, if this is 7 halves, we're going to need to multiply all of these by 2 to get rid of the denominator on the 7 halves. So 2 times 1, this is going to give us 2. 7 halves times 2 is going to give us 7. 2 times 2 is going to give us 4. 3 times 2 is going to give us 6. And that is going to be our new balanced chemical equation. Two molecules of ethane, C2H6, plus 7 molecules of O2 gives us 4 molecules of carbon dioxide and 6 molecules of water. While we're talking about combustion, the products of combustion are always going to be carbon dioxide and water. Okay, one way to remember this is think about yourself. You are a biochemical combustor. You take in fuel, you breathe in oxygen. On a cold day, you can see the water vapor you exhale, and also you exhale carbon dioxide. Okay, so you can always remember the products of combustion because you know what you breathe out. Now we're talking about stoichiometry. So let me rewrite this. Chemical equation here so that we can do a problem on it. And I'm going to scroll down just a little bit. Now let's say you have a problem where you're given a certain amount of one of the products. Let's say you're given 25 grams of ethane, and you want to know, let's say, how many grams of carbon dioxide do you get? All right. Now this is what we call a mass to mass stoichiometric problem. All right. Once you have the chemical equation balanced, you can work on solving these problems, and they're either going to be mole to mole, where you're given a certain amount of moles of a product or a reactant, and you have to figure out then this certain number of moles of the product or reactant. In this case, we're going mass. So this is the harder of the two because it requires the additional step. You're going to convert this into moles anyway and then convert back over. So it's just an extra step. So if I go through an example using mass to mass, then you're seeing it all through the steps that you would need to follow. All right, well, since our chemical equation is in terms of molecules. 2 molecules of C2H6 plus 7 molecules of O2 gives us 4 molecules of CO2 and 6 molecules of H2O. It also is in terms of moles. 2 moles of ethane and 7 moles of oxygen will give us 4 moles of carbon dioxide and 6 moles of H2O. So if we're given a mass, we need to convert this into moles. Okay, and how do we do that? Well, let's see. We have mass divided by formula mass gives us moles. All right, so yes, mass, we have 25.0 grams of this. We need the molar mass of C2H6. All right, C2H6, well, each carbon is 12 on the periodic table, so that's 24. Maybe I'll write that down here. C2H6 equals 2 of the carbons, and they're 12 grams per mole each. And we have 6 hydrogens. They're 1 gram each times 6. So this should be about 30 grams per mole. And I'm just estimating here. I don't have the numbers right in front of me. All right, so 30 grams per mole. And let's see, what else do we know? Well, let's do this math. I don't have a calculator right in front of me, and I'm going to smack myself for not, but you can wait just a little bit for me. So 25 grams divided by 30 grams is going to give us 0.833 moles. So we have 0.833 moles of ethane. Now, we need to go to the amount of carbon dioxide. And notice the ratio of ethane to carbon dioxide. It's 2 to 4. Every 2 moles used will give us 4 moles of carbon dioxide. So we have 0.833 moles. If we take it of C2H6, and we know then we have 4 moles of CO2 to every 2 moles of C2H6. That's going to cancel right there, and it ends up being 0.833 times 4 divided by 2, or just times 2, and that means then we're going to have 1.67 moles of CO2 formed. Okay, 1.67 moles of CO2 formed. But it's not asking us how many moles, it's asking us how many grams. But once we have moles of CO2, we need to get this into grams of CO2. Now, we used before mass divided by formula weight gives us moles. If we want to get mass by itself here, we multiply both sides by formula weight. Formula weights cancel, and we're left with mass equals moles times formula weight. All right, we know moles. We just need the formula weight of CO2. Well, let's figure that out. CO2. We have 1 carbon atom. That's 12 grams per mole. And we have 2 oxygens. They're 16 each, for approximately 44 grams per mole. Well, moles times formula weight. 1.67 moles of CO2 times formula weight, 44 grams per mole, gives us what? Should be about 73.5 grams of CO2. And hopefully you can follow through that. I can write down the steps here. Got to balance the equation first. Okay, if you have mass needs to go to moles. All right, then once you have moles, you have to apply it to the ratio in the equation. After that, that should give you the moles of the other. I'll just put moles of B, and we'll do mass of A, moles of A, moles of A ratio and equation gives you moles of B, and then moles of B to mass of B. And those are your steps. So follow through that, and if you have any questions, certainly email us.